Across the world, millions rely on clean energy, but almost no one knows how it's made. Today, you'll step inside that hidden world, a place where forests are grown like living factories and machines operate with relentless rhythm, where heat pressure and engineering compress sunlight into powerful fuel. In the next few minutes, you won't just see a production line, you'll witness an ecosystem of precision built to turn nature into energy at scale. Quiet, efficient, unstoppable.
Every wood pellet begins its life in fast-growing, carefully managed forests. Moisture, light, and time quietly shape the quality of the future biomass.
Each plantation block is planned like an industrial field of energy, not just timber.
3 to 5 years of steady growth prepare the trees for harvest.
From above, drones map, measure, and monitor every hectare of growing stock.
The journey starts in controlled nurseries, where thousands of seedlings are raised in unison.
Strong root systems create stronger trees and more consistent biomass quality.
Access roads cut through the forest, built for efficient harvest and logistics.
Weed control keeps nutrients focused on the trees that will become fuel. Millions of trunks stand like vertical reserves of stored solar energy.
Wind and weather harden the fibers, giving the wood its mechanical strength.
In just a few years, young saplings transform into a dense forest of biomass.
This is the ideal size for chipping and pellet production. Small, uniform, efficient. Every plot carries an ID, coordinates, and full traceability history.
Even the forest floor hints at the complete use of every part of the tree.
The harvest phase begins, turning standing trees into movable logs. Mechanized harvesters cut, delimb, and size each trunk with engineered precision. Friction heat marks the physical intensity at the very start of the supply chain.
Forwarders gather cut logs and bring them to roadside loading points.
From forest tracks to paved roads, the biomass begins its journey toward the plant.
At the mill gate, each truck is weighed to capture incoming biomass volume. Bark holds minerals and ash that will later be carefully removed from the process.
From open air to enclosed systems, raw wood crosses the boundary into the factory.
Digital tags keep the source, species, and certification linked to each shipment. Heavy machines are engineered to move reliably, even in wet and difficult terrain.
Kilometers of road translate forest biomass into industrial feedstock.
Beyond this point, strict industrial safety standards govern every movement.
The journey of raw wood steps fully into the world of engineered processes.
The first transformation from logs to chips in a high-power industrial chipper.
Each trunk is reduced to uniform chips that can be handled and dried efficiently.
Chips form a controlled, flowing river of biomass moving into the process.
Debarking strips away ash-rich bark, improving the final pellet quality.
Screens remove stones, soil, and oversized pieces before they can damage the line.
Chipping, debarking, and screening run as one continuous interlinked system,
Uniform chip size is critical for predictable drying and milling performance.
Conveyors carry chips constantly, feeding storage bins and dryers downstream. Cyclones pull dust out of the airstream, reducing explosion and fire risks.
Chip storage creates a buffer, so the pellet mill never has to stop.
Metal detectors guard the downstream machines from hidden metal fragments.
From mechanical preparation, the chips now enter the critical drying stage.
An automated control system maintains stable drying conditions hour after hour.
With one command, tons of chips start their journey through the heat zone.
The rotary dryer is a slow-turning furnace of warm air and moving biomass.
Wet chips fall into the drum, beginning a controlled reduction in moisture.
A biomass burner powers the process using renewable fuel instead of fossil energy.
As the drum turns, air and wood mix to create uniform drying conditions. Exhaust systems separate dust and vent clean, moisture-heavy air to the outside.
At the dryer exit, chips now hold around 10% moisture and are ready for milling. Metal detectors guard the downstream machines from hidden metal fragments.
From mechanical preparation, the chips now enter the critical drying stage.
An automated control system maintains stable drying conditions hour after hour.
With one command, tons of chips start their journey through the heat zone.
The rotary dryer is a slow-turning furnace of warm air and moving biomass.
Wet chips fall into the drum, beginning a controlled reduction in moisture.
A biomass burner powers the process using renewable fuel instead of fossil energy.
As the drum turns, air and wood mix to create uniform drying conditions.
Exhaust systems separate dust and vent clean, moisture-heavy air to the outside.
At the dryer exit, chips now hold around 10% moisture and are ready for milling. Fine grinding breaks chips into powder that can be compacted into dense pellets.
The chips are reduced to tiny particles between 0.5 and 1.5 millimeters. Powder flows into silos designed to keep the feed constant and stable.
Moisture content is checked again to confirm it is in the ideal range for pelletizing.
Blenders homogenize the powder, so every handful has the same properties.
A controlled feeder meters powder into the pellet press at a precise rate.
Inside the pellet mill, the spinning ring die is the core of the compression process.
Rollers force the powder through die holes, generating heat and pressure. The first continuous strands of pellets emerge, shaped under intense mechanical force.
Fresh pellets fall like a hot rain into the cooling section below.
Their glossy surface comes from lignin, the natural binder melted within the wood.
Automatic lubrication keeps the pellet press running reliably day and night.
Sensors continuously check pellet length, rejecting pieces that fall outside tolerance.
Pellets still at 80 to 90 degrees Celsius enter the cooler tower.
cool air moves opposite the pellet flow, taking away heat and moisture. Screens separate fines, sending broken pellets back for reprocessing.
Only cooled, intact pellets travel onward toward packaging and shipping. In the lab, ash content is measured to ensure it meets power plant and home heating specs.
Thermal images confirm that pellets leave the cooler at safe storage temperatures.
The result is a mass of uniform, dense pellets ready to be moved and bagged.
6mm pellets are the standard choice for many European household boilers.
8mm pellets serve larger furnaces, but both share the same production path.
Stable motor loads indicate a well-balanced mix of moisture, particle size, and feed rate.
Transparent sections allow operators to visually confirm smooth pellet flow.
Durability tests simulate long-distance transport and repeated handling.
Random samples are weighed to validate packaging accuracy later on. A dense, crack-free structure means more energy per unit volume.
Cooling and ventilation prevent self-heating and lower fire risk in storage. From powder feed to cooled pellets, the system behaves like a single integrated machine. Now, pellets are portioned into standardized bags for retail and small-scale users.
Bags are opened with bursts of air to receive a precise dose of pellets.
Each bag fills to a predetermined weight, checked by integrated load cells.
Heat sealers close the bags, locking out moisture and dust.
Robotic palletizers stack each bag in stable, repeatable patterns.
Stretch film secures the load for rough handling during transport.
In the warehouse, hundreds of tons wait under controlled, dry conditions.
Each pallet's label records batch, date, and specifications for full traceability. Forklifts move continuously, feeding loading docks and staging areas.
From storage aisles, pallets roll toward the dock and the waiting containers.
Pallets are placed like building blocks, filling the container from front to rear.
The last pallet completes a tightly fitting, high-density cargo of biomass.
Doors swing shut on dozens of tons of compressed renewable energy.
A numbered seal secures the container until it reaches its destination port. The container is lifted onto a trailer and coupled to its truck tractor.
Across the final flat miles, the speed of logistics accelerates, pushing the time-sensitive cargo toward its ocean vessel.
At the port, biomass shipments join the global flow of goods.
Cranes transfer the container from road transport to the port stacking system.
Parallel to logistics, the lab analyzes representative pellet samples.
Moisture analyzers confirm that pellets stay safely below 10% water content.
Ash furnaces burn samples down to residue, measuring the mineral fraction.
Calorimeters reveal how much energy each kilogram of pellets can deliver.
Durability tests ensure that pellets survive long journeys without turning to dust.
Diameter is checked to match 6 or 8 millimeter industry standards.
Independent labs certify that the pellets meet contractual specifications.
Certification documents prove that every ton comes from legally sourced timber.
Phytosanitary certificates clear the biomass for international movement.
EN Plus ratings distinguish high-end pellets for the strictest heating markets.
If this quiet world of precision engineering and hidden processes inspires you, then stay with us. There are countless factories, machines, and silent systems shaping the modern world, and we're just getting started. Subscribe to the channel, leave a like if this journey taught you something new, and share this video with someone who loves to see how things are truly made. Thanks for watching, and until the next factory opens its doors, stay curious. Before you go, I'd love to know something. Where are you watching from? And has your family ever used wood pellets for heating or energy? Tell me in the comments. I read every reply.